I know that I promised a course which is 100% hands-on, but in actual fact, we do need to go through a few slides just to get the terminology out of the way, because dependency injection and inversion of control are terms which are thrown around all over the place, but I think I better explain what they are before we actually start writing code. And we're going to begin with dependency injection. So let me give you a kind of motivating example, if you will. Let's suppose that we have a car object, and the car object depends on an engine. We can speak about it in terms of the car having an engine, and therefore you have to make a new engine and provide the engine for the car. Now, whether you call the constructor or whether you assign a property or whether this is something that's done implicitly, it doesn't really matter. The point is that we have a dependency. So we have a car which depends on the engine, and it needs the engine to be able to go somewhere. So in this case, we say that the car depends on the engine, and the engine happens to be a dependency. So it's something that the car actually depends upon, and obviously while the car is running you should have the engine functioning. So you cannot just assign an engine and then halfway through your trip kind of go and dispose the engine. That wouldn't be very smart. So the problem with this approach, the problem with the kind of code that I've written up above, is that manually supplying the dependencies is really not great for a whole number of reasons. So first of all, the first problem is that you have to supply the correct dependencies in every location where you need to make a particular component. So you need to make a car in 100 places, and in those 100 places you need to specify the right constructor parameters. And then of course what happens is you change the car, you do a refactoring where you add an additional parameter, and suddenly you have to add that parameter in 100 locations. Now, I know that in tools like ReSharper and Rider, you have this idea of the change signature refactoring, where you can actually resolve the missing arguments with a call tree, and you can do very sophisticated things in those IDEs, but still it's a bit of a pain. It would be great if we didn't have to kind of initialize the components all over the place. Another problem is that the engine itself might have its own dependency. So you might have a car which depends on the engine, but the engine needs oil and so on and so forth. So that once again, it becomes a kind of a very deep tree of dependencies, and satisfying this tree would end up you end up with a lot of boilerplate code, far too much code that is written. And in addition, keep in mind that a component might have a large number of dependencies. So a car depends on the engine, it depends on wheels, it depends on a driver driving it maybe. So all of these dependencies would have to be satisfied at some point or other. And yes, you can if you don't like the constructor, you can put them as property assignments and whatever, but it still does not really scale. It doesn't scale when you write sort of industrial sized applications. So that's the problem which dependency injection kind of tries to solve, and the solution here is in fact dependency injection, where all the dependencies of a particular component are provided magically. Now, of course, there is no real magic, but there is the possibility of using reflection, for example, to look at all the constructor parameters and initializing those dependencies automatically. So that's one approach. So what dependency injection does is it kind of obviates the use of the new keyword. So you don't need to use the new keyword anywhere. The idea is that you resolve some top level object, and when we say resolve, we mean create, but create through the dependency injection mechanism, not create by calling the new keyword. So this is the overriding goal. You don't want to be using the new keyword anywhere. You want to be using a container, which we'll talk about in a moment. The upside of this is that if you have deep dependencies, or if you have huge dependencies, like if you have a component which depends on 50 other components, for example, or, well, maybe not 50, maybe 10, 20, something like that. And I've seen systems like that, then you don't have to actually do all those initialization. You don't have to call any constructors yourself. All those dependencies, when you build a large dependency tree, everything gets resolved. And the way it works is very simple. So what happens is you still define the dependencies, obviously. So if you have a car and an engine, you still have maybe a constructor where you actually assign the engine and kind of store it in a field somewhere, or a property or something to that effect. That is still required. That's something that you still have to write. But then something different happens. So instead of actually explicitly constructing a car and providing it an engine, what you do is you configure an inversion of control container. So you configure a special object, which is called the container, which knows how to satisfy dependencies. And it's not just about the objects that you need to provide. It's also about their lifetime. It's also about the specific ways in which they're constructed, their relationships. There are lots of stuff. A typical dependency injection framework is sophisticated, and that's why this course exists, because I'm trying to explain all of the really clever parts in which the DI framework can help you in this regard. So what happens is you configure the container to satisfy the dependencies, and then you use the container whenever you want something. So whenever I want a car, I would tell the container, please give me a car. And this car could be anything. It could be a singleton, for example. It could be a car which is always the same car. Anytime I ask the container for a car, I get the same car. Or maybe I get one car per web request or something like that. So this is the gist of dependency injection and how it works. So essentially it's an automated mechanism for satisfying all the dependencies. Now there are upsides and downsides to this. So let's talk about the advantages and disadvantages. Now the advantages are fairly obvious. First of all, you reduce so much boilerplate, because you don't have to construct hundreds of objects manually. Instead, you just do a single call and all of the dependencies are satisfied, and it's a recursive process, because if your dependency has other dependencies, then those are satisfied. And the upside is, it's uniform. If you have to do it in 100 different places, well, you don't have to anymore, because now the system can do it for you and you don't have to write those huge chunks of code, basically. Another thing is, of course, that you tend with a dependency injection framework to have one central place where everything is configured. Now, it is possible to split configurations between different parts, different subsystems, for example, and Artifact provides modules for doing exactly that. We'll take a look at that. But the key idea here is that you reduce the number of locations where you have to explicitly specify who depends on what and how and what their lifetimes are and everything. Another benefit is that when you ship an application to somebody, you can actually externalize the configuration. So instead of having the configuration in a rigid scheme, for example, let me give you a simple example. Let's suppose you want to do logging in your application. Now, your client might want to put the log into the system Windows log, or they might want to start logging using FTP, or start logging using email or SMS or something else. And you can actually let them configure the injection so that whenever they ask for some iLog interface, they get the interface dependent on how they configure the container. And it's certainly possible to configure it outside of the actual code. So obviously your consumer, whoever is consuming your app, doesn't really have to, recompile your app or anything. They can just change a line in some JSON or XML file, and that will give them different functionality. So that is also very useful. Now, another benefit, as I've already mentioned, is lifetime control. The fact that with a dependency injection framework, what you can say is that different objects will have different lifetimes, and you have greater control over how long objects live and when they are disposed. Now, we have languages like Rust, which try to bake it into the language, try to bake the lifetimes and have this lifetime checkers and borrow checkers, but with .NET we don't have that luxury. So having the container which manages all your objects means it's not just managing them in terms of giving the right object at the right time, it's also managing their lifetime. And so, for example, you can make a component a singleton, you can make a component per request for ASP.NET, and so on and so forth. So this lifetime control is very useful. And well, I mentioned singletons. The dependency injection frameworks are probably the only socially acceptable way of actually making singletons, unlike doing it by hand in the classic way. And another benefit of all of this is, of course, encapsulation, and the fact that you essentially start working in a more kind of in a mindset where if your components provide some service, you kind of externalize it into an interface, and you provide that interface, and you once again you make everything configurable. That's how you can switch from one to another without recompiling anything. So encapsulation and basically working with interfaces and specifications is a lot it's a good practice, and it's a lot more convenient, especially when you're working with large scale applications where lots of people are working on an application. You could just establish a contract and then work to that contract and reconfigure the container to start using different services, different interfaces, and so on. Now, dependency injection does have its downside. So first of all, there is this problem that it creates a bit of an expectation that the configuration is done using the construction code. So essentially, instead of calling constructors, it's kind of implicit that you shouldn't be doing it. It introduces this mindset that you should do everything in the container, and this becomes problematic because some people, especially junior programmers, they might still want to try and actually invoke constructors and whatnot, which is of course not a great idea, and you can end up with a real mess because obviously when you're going to call constructors, you're going to try to satisfy some of their dependencies, but you're not going to be able to do it in a recursive way in a large scale system, so that's going to be problematic. So you have to communicate to your team that you have this kind of expectation that everything happens when you actually build the dependency injection container. Another problem is that now you've separated the behavior from the construction code, and that makes code somewhat hard to read because now you don't see the constructor parameters anymore. Now you don't see initialization happening in the kind of traditional C# way. Instead, you are looking at these chains of configurations for the container builder, and it's not the same experience. It's not the same thing. I'm not saying it's bad and terrible. You can certainly get used to it, but it's just a different kind of approach, and it's something that people might be uneasy about. Now, next up is, fairly obvious thing that you have to start up front using dependency injection. So sticking it halfway in between the development cycles is not the great way to go, because obviously once you've added a dependency injection container, you would have to literally search your code base for invocations of the new keyword for your components which you want to be injectable, for example, and you would be sticking them into the appropriate locations. Now this is it's also doable, by the way. It's doable in either Visual Studio or Rider. It's totally fine, but the problem is that you're going to be seeing lots of new calls on objects where it's okay to call new. So for example, if you make a new string, that's not something, you don't want to put string into the dependency injection container. You only want your types and your services in the container. So that's something that can be tricky. So having this dependency injection paradigm is best if you are starting out with including it right from the outset. Now, another thing that it can theoretically cause is an explosion of types and people making lots of interfaces, because essentially dependency injection it kind of drives you into the mindset of expressing components as services which they provide, and it's great for polymorphism and whatever, but in actual fact it can cause people to create a lot more types than are actually required, in particular because with the configurable lifetimes you can now split a component into several components with their own special lifetimes and manipulate them, and it increases the complexity of the system, and I'm sure you agree that complexity is not a great thing. The dependency injection container by itself is actually good for reducing complexity because you don't call so many, you don't do so many constructor calls by yourself. But on the other hand, a lot of complexity happens behind the scenes, and without a good understanding of how the container actually works, you're going to be in trouble. You're not going to be able to effectively figure out what's going on if, for example, some deep dependency somewhere isn't satisfied and you just get a very deep exception. So that's something to watch out for. Okay, so that's dependency injection, and the other thing that we have to talk about is inversion of control. Now, it sounds really scary, but in actual fact, the inversion of control principle simply inverts the control flow of a program. And let me give you a simple example which has nothing to do with dependency injection. So let's suppose you have a list and you want to add an element to that list. You say my list.add the number 42. And so the control goes from the list, and the list has a method called add, and that's where you actually feed in the value, and then the list obviously adds it to its internal storage. Now, it's possible to invert this control by writing some sort of extension method on a literal of type T, where you say 42.add to my list. So notice what I've done here. Of course, underneath, sort of behind the scenes, it would still be doing the ordinary add call because that's the interface we have for list. So you can think of add2 as some kind of an extension method. But what we've done is we've made a situation where instead of calling container dot operation and then argument, we said object dot operate upon some container. So instead of saying mylist.add42, we have 42 dot please add it to my list. So we've inverted control. We've inverted the control flow effectively. We've certainly changed the way that you actually see the code when you look at it. So that's a simple example of how you can invert control. And of course, dependency injection is a form of inversion of control. So it's one of the many different implementations where you can invert control. So here what we mean by that is the following. So instead of using ordinary object composition, where you call a constructor or assign a property to make an object consist of several other objects, you take all this responsibility and you delegate this to the IOC container. And the IOC container, where IOC stands for inversion of control, so this container is actually responsible for giving you a fully initialized object with all the dependencies that have been added. So you tell the container how you want the object to be built, and then when you ask the container for the object, it will build the object for you, satisfying all the dependencies that the component actually has.